Hello, my name is Itai Seggev. I'll be talking about the power of typesetting, and I will give a brief introduction into some of the principles that go into formatting inputs and outputs in the Wolfram language, and how we can make that to make interfaces more aesthetic and also more usable. So, what is typesetting? We can mean a few different things by that. There's front-end typesetting, which sometimes is called box rendering, 2D editing. This is the visual appearance of box expressions, creation of modification of them in response to user actions. So if you don't already know, your notebook that you see is a Wolfram language expression in a particular subset called the box language. And so the front end takes that notebook, converts those expressions into beautiful things which you see, like square roots and fractions and all that good stuff. Then there's kernel typesetting, also called output typesetting, output formatting. This is the conversion of the Wolfram language expressions to the box language for transmission to the front end. So when you type something in, well, actually I should say that next. And then there's kernel untypesetting, which is also called input typesetting or box interpretation. This is the conversion of box expressions sent by the front end into normal expressions to be evaluated by the kernel. So you type something into your notebook, and something gets created. There, and you see the word box. So this is a box expression. And when you hit Shift-Enter, that box expression gets sent to the kernel. The kernel turns that box expression into the actual input that you mean to evaluate. It evaluates that input, then it converts the result back to the box expression, and it transmits that box expression for the front end to insert into your notebook, and then display. This talk will be primarily about kernel typesetting, this stage of taking the output and converting it into something pretty. I have no control over front-end typesetting other than pestering the people in this room who do have control over it, and every now and then they make me go away by actually doing what I'm pestering them. I also do a lot of kernel untypesetting, but this talk is not so much about that, although I'm happy to answer questions about that. So some related talks. The typesetting workshop by Jason Harris will be here next. It'll talk some more about some of the front-end aspects, but also the typesetting and untypesetting stages. What's new in calculus and algebra, if you're interested in that aspect of the talk, that'll be this afternoon by Devendra and Adam. If you care a great deal about how things look and the exact number of pixels between the fraction line and the square root underneath it, then go to the math typesetting roundtable, which is tomorrow at 1 p.m. So that's really the front-end typesetting business. Lou will be talking about some related aspects to output formatting related to this talk. And then for more about limits, which will feature prominently in this talk, but primarily their appearance, not so much all the functionality, that'll be tomorrow at 4:30. And I shall briefly mention, but not go into the details of the init code that does not appear in this talk. I should mention, with one very small exception, everything that I'm going to show you is in 11.2. So you should expect to see this and be able to play with it. So some principles of output formatting. Output formatting is supposed to faithfully represent the result for later use as input. So that means if you take the output, paste it into an input cell, and reevaluate it, you should get the same thing you got as above. So that in particular means it can't leak. It can't somehow evaluate part of the expression and change it. One of the things we try to do, and you should also try to do, is to restrict formatting to valid expressions. This helps reduce leaks. It also makes it sort of easy to tell what's, some random expression which happens to have had sparse array but isn't really a sparse array, as opposed to an actual honest-to-goodness sparse array. It needs to be fast. People get very annoyed if their computation takes 0.1 seconds, but then they have to wait 15 minutes for the result to be formatted. Not that anybody has ever reported a bug against me to that effect. Also, avoid messages. You want users to know that the messages they see come from the code they wrote, not from your random formatting code. So those are some basics, ideas you want to keep in mind. So we have two main output formats in notebooks, standard form and traditional form. Standard form wants to be unambiguous to the extent that it's possible. It should be typable and editable, right? You should be able to just type it in using keyboard shortcuts if necessary, and edit it. There are some exceptions, like graphics, right? They format as things you see because they're visual things. Controls, right? It would be not very useful if a slider formatted as the input form of the slider, but not as an actual slider you can slide. And we try to be sort of as close as possible to the underlying structure. By contrast, we have traditional form, which should look traditional. That can mean different things. Not everything has a sort of traditional form, but sort of, to the extent that there's a mathy traditional appearance for something, that's what we try to customize, what we try to target. We try to allow for some customization, which I'm going to be talking about. And in the service of these couple of important goals, we might sacrifice the typability, we might hide structure, or give different expressions similar or identical appearance. So let's illustrate those differences. So here I have what looks like two column matrices with A and B in them, and so they should be equal to each other, and I evaluate them, and I get false. And here I have three things which I'm claiming they're not equal to each other. They're all different from each other, even though they all look pretty identical. But in fact, these are three different things. And here I have M inverse is equal to M inverse. Surely that one must give true, and yet it does not. So what's actually going on here? So the first input is actually the matrix AB and binomial of AB. If I had not cleverly moved my mouse in order to hide this fact, you could have seen that this may be too small to read from the screen, but there's a little tooltip there which says this is a binomial. Whereas if you just sort of go over here, no tooltip. On the other hand, with theta, we have one just plain theta of t, then we have Heaviside theta, then we have unit step, and the unit step and the Heaviside theta have little tooltips. This random theta of t that I typed in does not have a tooltip. Let me point out that these two left-hand sides you can just type in. I mean, I quite literally did just open some parentheses, create a row matrix, type AB, and if this were a traditional form cell, this would be interpreted as a list. I guess even in standard form, this is interpreted as a list, although it doesn't format like that by default, whereas in traditional form, it formats using the parentheses. Whereas this Heaviside theta of t is not so easy to type in. And this last one, well, they're both inverses, but they differ in options. And because these both say inverse, so you know it's an inverse, but you don't really know that these are two different M inverses, which is slightly unfortunate, but on the other hand, if you're really looking to make a nicely formatted output, that's probably for the best.
Just while we're there, if you click in your input cell input commit N7 and
Yes.
It's quite nice sometimes to do that. Hit Command-Shift-N right there, and then Command-Shift-T, Command-Shift-N, Command-Shift-T, and you can actually see it cycling through.
Yeah.
And it's,
Yes. On Windows and Linux, that would be Control-Shift-N and Control-Shift-T. So I don't know how we got from standard to N. Maybe that's normal appearance. The T is pretty easy to figure out. So those are two useful shortcuts. So yes, oftentimes. So for
What is the shortcut again?
the shortcut is Command-Shift-N converts. So you select the cell by clicking on the cell bracket, and you hit Shift-Command-N or Control-Shift-N if you're on Windows and Linux, and it converts it to standard form. And if you hit Command-Shift-T or Control-Shift-T, it converts it to traditional form. Okay. All right. So what are some recent advances? So the number domains, and there are actually 7, but I'm going to focus on 4, the 4 familiar ones: integers, rationals, reals, and complexes. Before 11.2, they only formatted in traditional form. They actually didn't have any tooltips to allow you to distinguish them, and they had no customization. And so this cell here, I put in a secret option to make it use one of my older Mathematicas to evaluate. So this is evaluated in 11.1.1, and you see that in standard form, they just formatted as their names, but in traditional form, you got these, traditional domain notation. So in 11.2, they format in both forms. They now have tooltips, and they're customizable. So if I were to evaluate this example, we see that they formatted in both forms. And if I hover over them, there's a little tooltip, which if you're really close to the board, you can tell says complexes. All right, so our first customization example. So this customizing involves learning a little bit of the box language, or a lot, depending on how much customization you want to do. But this is a very simple example. If we call makeBoxes, which is the function the kernel uses to turn its output into the box language, then we see that this creates a template box named reals. I'll talk a little bit about that empty list in a bit. So if we want to customize this, we can go to the Format menu and say Edit Style Sheet, and we can create a new style called reals. And then, so that's down here, and let me increase the magnification so you can actually read something. So there's reals. Yeah, that still looks a bit small. I will make it, a bit bigger. Reals. And then you unformat the cell. I did that using Command-Shift-E or Control-Shift-E on Windows and Linux. You could also have done that using cell show expression, is how you do it from the menu. And now you will paste in the following code. Template box options goes to the list and display function. Here I'm going to change it from a double struct R to a Gothic R. So I'm going to copy this code, going to go to this menu, going to insert this code, comma, and now when I reformat this cell, then you see the R change from a double struct to Gothic. So let me do that. Well, I guess I'd have to delete it. So if I delete it, it goes away. If I paste it back in, it becomes Gothic again. Now, because this process is a little bit tedious, I actually, in that init code, which I didn't show you, I created 2 functions which do this. So if I clear the formatting, and why did that not work? Why is that not working? Okay, that's slightly, oh, it was working. It was just slow for some reason. Okay, so here I have a slightly fancier version where I disabled syntax coloring and I forced the font family to, so it always has uniform appearance no matter where you stick it in. All right. So, oh, and I guess I didn't show off the one new, so we have these new key input shortcuts I mentioned, and one of the nice new features in 11.3 is that these shortcuts complete, so shortcuts not just for characters, but also for formatted expressions, so I can select ints, and voila, there's my integers. Okay, limits in standard form. Okay, so in 11.2, limit has been upgraded and it has new friends, max limit and min limit, discrete limit, and discrete versions thereof. In standard form, they format using new limit operators. So we have nested limits, which are sort of iterated limits. We have multivariate limits. So how do you enter these guys? Well, you use the new limit characters. You enter either subscript or underscript. If you know what limits positioning is, it obeys limits positioning. And you can use from above or from below in sort of the obvious way. So here I have a pre-formatted example. I evaluate that. That used to return infinity. Now it returns indeterminate because the two-sided limit is now the default. So the following is sort of an equivalent input. But to illustrate, I can type in lim. I can hit Control-4 to enter an underscript. I can say x goes to 0. I can select that rule and hit Control-4 again, and now I can insert complexes. And now I can type in 1 over x, and now I will get a different answer. I'll get complex infinity because we're taking a limit in the complex plane. And so you know, 1 over x maps 0 to the point at infinity. Now, that's a limit from above because I put in a superscript. I can also, do x goes to 0 and put in a superscripted minus and take the limit of 1 over x. And now I get minus infinity. Okay, ooh, I am running low on time. All right, so now you could type in the discrete limits by hand, but that gets to be a little bit tedious. So we created, again, these shortcuts. For example, dlim for discrete limit, and then you take the limit as n goes to infinity over the integers of sign of n. That doesn't exist, but the max limit and min limit do exist. I have a little note. In some situations, it will not work for you. I'm going to skip that. If you've upgraded from previous versions, I explain how to fix that if these shortcuts don't show up for you in that little note there. Okay, so briefly, let us compare standard form and traditional form. So here's our, this is the standard form appearance we had. Now, you'll notice that in traditional form, we don't have these underscripted z's, say, for the discrete limits, because I thought people would kill me if they saw this non-standard z in the output. Although surprisingly, Paul, somebody complained about this. We can talk about that later. Comparing the standard form and traditional form, clearly the traditional form is more traditional. This isn't something you can really type in. I haven't really shown that. but it's more customizable, and that's a common trade-off. I will, the basic process is basically the same as what we did before. We first look at the boxes, and here I just have a simplified input. And we see that it creates a template box called discrete limit. Then you have the arguments, and you notice, or at least pieces of the arguments appearing in different slots here in the list. And these positions in the list are things you need to reference when you create the display function. So I'm going to create a new style called discrete max limit, and I will create a row box. So this is getting a little bit technical. If you know the box language, it's pretty straightforward. But I'm going to now, instead of using an overline lim for lim soup, I'm going to use lim soup. So we want an underscript box. Then we want to and then the second argument, the X, arrow, third argument, the A, and then after the underscript box, we want the first argument, F. And so we do that, and if we go up here, then nothing has happened for some reason. There we go. And now this overline thing has become a lim soup. And similarly, we could do the same process for the lim inf, and we get lim inf. Now with I'm really don't have time to go through this, but I will just briefly mention with the continuous versions, it's more complicated. Rather than max limit, there's something called max limit to arg. And that's because you have different directions. So in fact, there are 3 different types. There's max limit to arg, there's max limit with tooltip, and there's max limit with the superscript. And I will let you peruse the take-home recipes from the comfort of your own home if you want sort of very fancy. Basically, I show how to convert everything to a nicely formatted lim soup, lim inf, and also how to use up arrow and down arrow rather than a superscripted plus and superscripted minus for limits from above and limits from below. There's also a little technical note on limit that you should read if you want to customize the appearance of limit, although I don't expect that to be a super common desire. Okay, summary boxes in the minute and a half I have left. So briefly, summary boxes have a different set of trade-offs because they fill a different need. They're used for cases where the full form is for some reason not what we want to see. So it might be too big, it might represent an external object, or it might be a case where we're optimizing for performance, so we want to avoid seeing the complete expression. We try to visualize the data where possible, and we're going to sacrifice any editability to achieve these goals. So to illustrate what I mean by this, I will time series. So you'll notice that this icon here is sort of bluish and pretty, and that indicates that this is a visualization of actual data, this random 25 numbers I generated here. Whereas this one is a gray, all gray. That means this is sort of a generic icon because it couldn't create a visualization, because how do you plot the string A, the string B, and the string C? So one of the new features in 11.2, so sparse array used to be one of these outputs which you couldn't use as input because we didn't want to sacrifice performance to embed the whole big sparse array into a notebook. So we've come up with this new system where for small inputs we do put it in. So I can copy this sparse array out and insert it into a new cell and it evaluates. For big ones, we don't embed it, but we now have a notebook, a button that you can insert the full expression into the notebook if you so desire. So you've done a long computation, it gives you some answer, you want to save this for later results, you press that button. Now, if each one of these sparse arrays is, 50 megabytes in size, you may not want to do that at every single step, but certainly, for the last one, you probably want to save your results. And just a brief illustration, this will be really hard to see, but one compiled function here has WVM for Wolfram Virtual Machine, and the other icon has C to indicate one was compiled to C, one was compiled to the Wolfram Virtual Machine. So I am over time, so I will just briefly, yes, you can again peruse the summary box creation guide if you want to create your own. Typesetting allows input and output in natural forms. There are various trade-offs you need to balance, but ultimately the goal is not just to look beautiful, although that's always nice, but to make something usable for the task at hand. And I would like to briefly acknowledge two teams here, the Symbolics team, of which I am the multicolored sheep of the family that makes pretty things. And the typesetting team, who has taught me many things over the years to help me make the Symbolics code more pretty. And I will just briefly list the talks if you are interested in them. I will be available for now for a bit, and also at 1 o'clock I'll be downstairs in the Symbolics booth, so feel free to come by and ask me any advanced questions you would like to ask me. Thank you.